Hello everyone, welcome back to my YouTube channel. So now I'm going to solve problem number 3463. Check if digits are equal in string after operations 2. So this is a hard level problem marked by LeetCode. So without any delay, let's read the problem statement first. So in this problem, you are given a string S consisting of digits only, right? We have to perform the following operation repeatedly until the string has exactly 2 digits, right? For each pair of consecutive digits in S, starting from the first digit, we have to calculate a new digit as the sum of the two digits modulo 10, right? And then we have to replace S with the subsequence of newly calculated digits, maintaining the order in which they are computed, right? And in the end, we have to return true if the final two digits in S are the same. Otherwise, we have to return false. So problem statement is similar to the part 1 of this problem, right? So if you see this part 1, right, this one, right, problem number 3461, check if digits are equal in string after operation was 1. So we have solved this problem yesterday, right? So similar problem statement, right? And if you see the examples of today's problem, so examples are also same here, 3902, right? And here also 3902. Okay, so here what we need to do, right? So 3902 we have, right? So we have to take these two, right? So 3 plus 9 is 12. 12 modulo 10 is 2, right? Then we have to take a 9 plus 0 modulo 10 is nothing but 9 only. And then 0 plus 2, 2 modulo 10 is nothing but 2, right? So here if you see this string is having length 3, right, not 2. So again we have to do the operation. 9 plus 2 11. 11 modulo 10 is 1. 9 plus 2 11. 11 modulo 10 is 1, right? So now if you see this string, right, length is 2, right, and this digit is similar to this digit, right? Both are same, so we have to return true, right? So this is what we have to do. 3902, we get 292, and then after that we get 11, right? And here, since the digits 1 1 are the same, the output is true, right? So same, right? Now if you see this 3461 part 1, right here, so if you see the constants, so s dot length from 3 to 100 only, right? And s consists of only digits, right? So if you see this code, right, so this loop, line number 8, so this loop is running approximate of n times, right, in the worst case scenario of n, right? And this loop also, it is also running of n times, right? So I have solved this problem yesterday, so I will add the link in the description if you want to check out this video, right? I will add that so you can check out. But here in this case, the total time complexity was of n square, right? But now if you see this problem, right, here the constant size 3 s dot length from 3 to 10 raised to power 5, right? Constant size is very large, so 10 raised to power 5 square, that is simply means 10 raised to power 10. So that simply means that we are going to get time limit exceed error, right, for this part 2 of problem, right? So that is the reason this problem is marked hard by LeetCode, right? So now let's see how we are going to solve this problem. We have to solve this using the optimal approach, right? So let's take this first example, 3902, right? So here first example is 390, right? So what is the length of this string? It's 4, right? So let's say this is my string a b c d, right? So in one operation we have to do the addition of these two, right? A plus b, and then we have to do the modulo with 10, right? Here we have to do b plus c, then modulo 10, right? And here we have to do c plus d, then modulo 10, right? This is what we have to do right here. Okay, so now what I'm going to do here, let's say I'm just writing a plus b only. I'm not writing modulo 10 as of now, okay, just for reference. So b plus c, and here this is nothing but c plus d, right? So this is what we are going to get, right? Again, if I do perform the same thing, So now I have to do the addition of these two and then addition of these two, a plus b, and here again b plus c, right? This, and here this is nothing but b plus c plus c plus d, right? This is what we are getting, right? So here in the end, if you see, we are going to get okay, we are going to get this as a plus 2b plus c, right? And this is nothing but b plus 2c plus d. That's it, right? And now we have two digits, right? So here, same way here also, if you treat this as a, this as b, this as c, this as d, right? And in the end, if you just simply apply this formula, right? So a is 3 plus 2 into 9 plus c is nothing but 0, and here same formula, b is nothing but 9 plus 2 into 0 plus this d, that is nothing but 2, right? So here this is nothing but 3 plus 9 into 2, 18 plus 0, and here 9 plus 2 only, right? And here this is nothing but 18 plus 3 is 21, and here 11, and we have to do modulo 10 everywhere, right? So let's say I'm doing modulo 10 here, modulo 10 here. So what I'm going to get, I'm going to get 1 here, I'm going to get 1 here. So see, both are matching, right? So we have to return true, right? So here, see, in the final output, okay, whatever the final output, we are getting final output like this, right? If I just show you like this, a b c d, right? So in the final output, we are just using these digits only, right? These characters of string, right? Right now these are digits, right? So I can say these digits only we are using in the end, the original digits, right? And in the output, here there is nothing, that simply means I'm using a only one time, right? Here we have 2, b means 2b means I'm using b 2 times. Here there is nothing, means I'm using c only one time, right? In this side. And here I'm using b one time, c 2 times, and d one time, right? So I can say that these are nothing but the coefficients, right? 1 2 1, right? These are nothing but the coefficients, 1 2 1, right? So these are nothing but coefficients, right? And if I know these coefficients, right? If I know these coefficients, 1 2 1, 1 2 1, right? If I know these coefficients, then what I need to do, coefficients are same here also. If you see 1 to 1, here also 1 to 1, coefficients are same. Here if I have string like this, so in this side I'm using, I'm starting from here, I'm taking the next three, right? 1 2 3, total 3, 1 2 1, 3 are there, right? So I'm starting from here, and then I'm taking a b c, right? So here if you see a b and c, right? Like I'm using a here, then addition with b, and then addition with c. And here in this side I'm starting from the next one, right? Here I'm starting from a, here I'm starting from b. So b, c, and d. So b one time, c two time, and d one time, right? Right, like this. Clear, right? So I have to know about these coefficients, right? Now let's take one more example here. 3 4 7 8 9, right? 3 4 7 8 9, 3 4 7 8 9. So here if I just write string a b c d e, right? And this you know, right? 21 modulus with 10 is nothing but 1, right? Okay, this, let's say this is the final result, final result, right? 21, can I write this 21 like this, 11 plus 10? Yes, I can write it like this. So this is also nothing but 21 only, right? And here 11 modulus with 10 plus 10 modulus with 10, this I can do here, right? 11 plus 10 modulus 10, I can write it like this, 11 modulus with 10 plus 10 modulus with 10, right? So this is nothing but 1 plus 0, so this is also 1, right? So whether we do the modulus 10 in the end of the final result, or whether we do the modulus 10 side by side, so we will get the same output always, right? So here, that is why here instead of doing a plus b modulus with 10 plus b plus c modulus with 10, c plus d modulus with 10, and then overall this modulus 10, this modulus 10, I can directly do it in the end also, right? So that's what I'm telling here. Okay, so here this is your string. So here how you're going to write it in the next time: a plus b plus c plus d, and d plus e, right? So now initially we have five characters, right, in this string. Now we have four digits, you can say, right? Four digits. Next time, a plus b plus b, that is nothing but 2b plus c, right? So this I need to do, right? And here this is what I need to do, right? So b plus 2c plus d, and here this is what I need to do, that is nothing but c plus 2d plus e, right? So now we have three, right? Now after that, 5 4 3, and now we, after this, but we need to do a plus 2b, it is going to become 2b plus b 3b plus c plus 2c, that is 3c plus d, right? This is one. And here it is going to become b plus 3c plus 3d plus e, right? b plus 2c plus d plus c plus 2d plus e is nothing but this one, right? So now in this case, if you see, the coefficients are 1 3 3 1, right? Let me just mark it like this. So now if you see, okay, now you see here coefficients are 1 3 3 1, here also 1 3 3 1. If I treat this as a b c d e, so here first a b c d I'm taking, and here in this side I'm taking b c d e, right? Now if you just apply the formula, 3, right, one time 1 into 3 plus 3 into b 3 into b plus 3 into c 3 into 7 plus d8. So what I'm going to get here, 3 plus 12 plus 21 plus 8, right? And this is nothing but 15 plus 29, that is nothing but 9 5 14, 1 here, 2 3 4 44. I am getting 44 here, and 44 modulus with 10 is nothing but 4, right? This is what I'm getting. This is my LHS, left hand side digit, right? We are going to get two digit sides, and this digit, let's calculate this as well. So b, let me use some other pen, let me use brown, right? Now b is nothing but 4 plus 3 into c, 3 into c is nothing but 27, right? And here 3 into d, 8 3 24 plus e is 9, right? This, okay, and this is nothing but 25 plus 24 plus 9, and this is nothing but 25 plus 24 is 49, 49 plus 9 is 58, right? And 58 modulus with 10 is nothing but 8. So I am getting 4 here and I am getting 8 here. Both are not same, right? We have to return false, right? So see here, we are getting 4 this side and 8 this side, right? So this is clear, right? So here also I'm dealing with the coefficients only, right? So, and one more thing is clear, that in the final output, I'm just using the A, B, C, D or B, C, D, E, right? Or I'm only using these original digits only in my final output, right? Okay. So here in the part 1, instead of calculating the result in of n square, right, I can calculate the result directly, right, if I just know the coefficients, right? So I hope that this part is clear, right? Now here one more thing I want to tell you. If you see here, this one is having length 5, right? And in this output, if you see, this is one side and this is one side, right? So we have total 4 coefficients, right? Total 4 coefficients, this one, this one, this one, this one, right? So what I can do here, length is 5, right? 3 4 7 8 9, 3 4 7 8 9, length is 5, right? Length is 5, and here I'm going to calculate one value limit, and in this limit, this length is 5. In the end, how many, what is the total length I need of the string? I just need the length 2, right? So I'm going to subtract 2 from it, so I'm going to get 3, right? So now this 3, limit this 3 is nothing but the value of this limit, right? 5 minus 2, because in the end we need length 2 of the final string, right? Final string, right? So 3 we are getting. So now here 0 1 2 3, right? I'm going to write this limit 3, right, as 0 1 2 3, starting from index 0 1 2 3, right? Because here if you see we have total 4 values, 4 coefficients we are using, 1 3 3 1, right? And total 4 digits only we are using in the final, right? And I'm going to show it like this. This is at 0, this is at 1, this is 2, this is 3, right? Okay. And here I can also write this like this. Okay, limit is 3, so I'm going to write 3c0, 3c1, 3c2, 3c3. Okay, right, these are nothing but the binomial coefficients. Actually, we will discuss about this in some time now. Binomial coefficient. So here this is nothing but the limit, and here we are getting 3, so I'm going to write first j0, j as 1, then j as 2, then j as 3, right? So 3c0, what is the value of 3c0, right? So how we calculate the value, I just give you one hint: 3 factorial, 3 factorial, and 3 minus 0 factorial, like this. So this value is nothing but 1 only, right? And here 3 factorial, 1 factorial, and here 3 minus 1 2 factorial. So this is nothing but 3 only, right? 3 into 2 factorial, and here 2 factorial cancel out, so this is nothing but 3 only, right? This is also 3 only, 2 and 1, this is also 3, and here 3 factorial, 0 factorial, and 3 factorial, right? So this is also nothing but 1 1 3 3 1, right? So this is what I'm getting here, 1 3 3 1, right? So how we are going to calculate this binomial coefficient? Okay, so we will discuss about this. So I have all these details here, right? How to calculate the binomial coefficient and what does this mean. I will come to this in some time. Okay, so first let's see this this example also. 3902, right? 3902, 3902, right? So 3902 here, uh, what are the coefficients we are getting? We are getting something like this. First, length. Okay, you are going to calculate the length of this. Length of this is nothing but 4, right? Limit, how you are going to calculate the limit? 4 minus 2, right? So that is number 2. So you have 0 1 2, right? And here 2 2 2. Okay, here c, and here what is the value of this? This value is nothing but 1, this value is nothing but 2, this value is nothing but 1, right? So 1 to 1. So this is one part and this is one part you're going to get. So 1 2 1 1 2 1 are the coefficient, and here first you have to write 3 9, and here 0, then here you have to write 9 0 2, right? This is how, and then you have to do the addition here. So 3 plus 9 into 2 18 plus 0, so you're going to get 21. Here this side you're going to get 9 plus 2 11, right? Okay, so this is what we were doing right here, so that's why I'm writing it directly here. If you see here, right, 3 into 2 into 9 21 11, right? This is what we are doing. So 1 to 1 is the coefficient, right? And this is the coefficient that we are getting here, like this, right? Okay, 2c0 and 2c1 2c2, right? These are the coefficients that we are getting here. Okay, and right now you are seeing everything like this, 1 2 and 1, right? These coefficients that we need, right? These coefficients that we need, right? Okay, these values can be very large, right? Here this is nothing but your limit value coming out as 2, but let's suppose if your string length is very big, right? If string length is very big, let's say string length is 900 9000, right? Now if you calculate the limit of this, right, this is nothing but the length of string 9000. If you calculate the limit, you are going to get something like this: 899 8. right? If you subtract 2 from it. So now you have to calculate first C0 for this, then 8998C1, like this until 8998C8998, right? This is what you are doing, right? Limit you are writing here, and then 0 1 2 until the end, right? So here if you write it like this, so definitely here if you solve this, this is very easy, right? But sometimes let's say you are calculating some very big, right? 898, and here for this particular part if you consider 0 and here 8998, so here we can directly cancel out each other. But let's say there is one case where you need to calculate this 8998, right? This is a very big value, right? This is very big value, right? So definitely we need to some better way to solve this problem, right? This value is very large. So what I'm going to do, I'm going to, instead of calculating the binomial coefficient directly, I'm going to calculate the binomial coefficient with mode, right? Mode 10 we have to do, right? So I'm going to calculate as binomial mode 10 value directly, and in that I'm going to pass limit and the my j value one by one, right? J is nothing but 0 1 2 until limit we have to pass, right? So binomial mode 10 I will calculate, right? So if I'm going to calculate the binomial mode 10, so I will get some smaller value, right? So binomial mode 10 means I will get values like this only: 0 1 2 3 4 5 6 7 8 9, right? That's the meaning of mode 10, right? Mode 10. So if you have number like this 8 9 9, so what is the mode 10 of this? Mode 10 of this is nothing but 9, right? This is nothing but a remainder, right? 899 10, right? Into 890 889. If you just multiply it with 89, you're going to get 890, right? So remainder is 9, right? So this is nothing but remainder 9. Okay, so this is what we need to do, right? So I'm going to get those coefficients in this range only, right? 0 to 9, in this range only. All right. Okay, so now let's understand this first. What is binomial coefficient and all? Okay, so this is what we are going to go over now. So binomial coefficient C n k, it means choosing k items from n. Choosing k items from n. For example, if I ask you to calculate the value of this C52, it means choosing how many ways I can get 2 from 5, right? So I'm going to get 5c2. So 5c2 here 5 factorial, here formula is like this: c n k formula is like this, n factorial, here n minus k factorial, and here k factorial, like this. So here I'm writing 5, here I'm writing 2 k factorial, and here 5 minus 2, right? So 5 factorial is nothing but 5 into 4 into 3 into 2 1, right? 5 factorial is nothing but 5 4 3 2 1, right? Factorial means like this. 2 factorial is nothing but 2, and here 5 minus 2 is 3. 3 factorial is nothing but 3 into 2, right? If you can cancel out these two, so you are going to get in the output as 10, right? This is what you are going to get, 10, right? And here if you see, let's say you have a b c d e name books, right? All these books you have. Okay, so in how many ways you get 2 books? In how many ways you set 2 books out of 5? So these are the 10 ways, right? These are the 10 ways. If you see here, you can select a b a c a d a e b c b d b e c d c e d e, right? We are going to select 2 books out of these 5, right? So total 10 ways, right? 1 2 3 4 5 6 7 8 9 10. That's it. Clear? Now we are also going to use this mod 2, right? Binomial coefficient mod 2, right? So what does this mod 2 means, right? So I didn't tell you where I'm going to use it yet, but we are going to use it. So first let's understand what does this mean. So when we say modulo 2, We mean we only care if the number is even or odd. So if the number is even, I'm going to say 0, and if the number is odd, I'm going to say 1. 1 for odd and 0 for even. Okay, so instead of calculating C and K, we only want to know if it is even 0 or odd 1. Okay, so here few examples if you see. So n is 4 and k is 2. So what is 4 factorial 2? This. Okay, what is C 4 comma 2? Right, I can say this. So this is nothing but 4 into 3, and here 2, right, and here this 2 factorial and here this 2 factorial, both are going to cancel out each other. So here 2, 3 into 2 is 6. So here if you see, we are getting 6, right? 6 value. Right, now if I do the modulo with 2, 6 modulo 2, so 6 modulo 2, remainder is going to be 0, right? So here I'm getting 0, right? So if you see this part, so we are going to get 0. So that means this is even, right? Here same way, 5 and 2, so C 5 comma 2 is nothing but 10, and we are going to get 0 here. Here C 6 comma 2 is equal to 15, and we are going to get 1 now, right? So 6 factorial is nothing but 6, and here 2, and here 4 factorial, right? Here it's nothing but 6 into 5, 4 is going to cancel out, here 2, so 3 into 5, 15, right? And 15 modulo 2 is 1, right? Odd. Same way 35 is odd. So here if you see, clear, right? So we just need this C of nk mod 2. So first we are going to calculate the value of C of nk, and then we have to do mod 2, and we are going to get 0 if it is even. This value is even, then we are going to get 0, otherwise we are going to get odd, right? Okay, so all right, this is done. Okay, and here if you see, if you also do one more thing, instead of calculating the C and K value, right, this can be very large, right? There is one shortcut to get this 0 or 1, right? That shortcut is, here we have 4, here we have 2, right? So how I'm going to write 4 in binary form? Bits values like this, 1, then 2, then 4, then 8. This is nothing but 2 power 0. This is nothing but 2 power 1, right? And this is nothing but 2 power 2. This is nothing but 2 power 3, right? So 4, how am I going to write 4 in binary form? So 4 I'm going to write like this, 1 0 0, right? This is how I'm writing 4. And how I'm writing k? I'm writing k like this, right? K. Okay, so now here if I do the AND of these two, right, so what I'm going to get? So there are no common bits, right? So I'm going to get 0 only, right? If I do the AND, there are no common bits, I'm going to get 0 only, right? So here N and K, here I'm getting 0 0 0, and what is my K? K is nothing but 2. 2 I'm representing like this. So both are same or not? They are not same, right? False. So if they are not same, false value is coming, right? So false means just give 0. 0 means even, right? So here we have even, right? Now if you take any other example, right? So let's say this example, 6 and 2, right? So how you are going to write 6? 6 you are going to write like this. Here here you are going to write it like this, 6, and 2 you are going to write like this. So output, in the output you are going to get something like this, 0 0 1 0, right? So 6 here, and here we have 2, so 0 0 1 0 now, right? 0 0, and here we have 1 0, right? For this value, right? So this and this both are matching, so that simply means both are matching. True, true means 1, 1 means odd, right? So this is one shortcut, right? Modulo 2, for modulo 2 we have one shortcut now, right? This is the shortcut for modulo 2. Okay, all right. Now there is one more thing we are going to study, binomial coefficient modulo 5, right? So if you see here, while explaining I was just discussing modulo 10. I was discussing modulo 10, right? I was discussing about modulo 10 only, but now I am discussing modulo 2, and now after this modulo 2 I am discussing modulo 5. So definitely there is some link between these three, right? Using this modulo 2 and using this modulo 5, I am going to calculate this modulo 10, right? And for modulo 2 we have already seen one shortcut, right? Now let's jump to modulo 5. Okay, let's see. All right, so okay, so we are here, right? Now if you see here, so this is the formula to calculate the binomial coefficient. So a plus b and power n, right? So this is the formula. Okay, let me just erase this, right? So a plus b power n is nothing but nc0 into a of n b of 0, right? So this is the formula that we have studied in class 9th or 10th, right? All right, so here nc0 into a of n b0, then after that we take nc1 into a of n minus 1. So initially a is n complete, b is 0, then after that if you see a is decrementing by 1 and b is incrementing by 1, a n minus 1, a n minus 2 decrementing. In the end a is going to remain 0, right? And b is incrementing everywhere, b1 then b2 then bn minus 1 then bn, right? B is incrementing everywhere, and here nc0 nc1 nc2 ncn minus 1. So this is how we used to remember this formula, right? So here if I ask you a plus b power 0, calculate this. So n is 0, right? So if I apply n 0 everywhere and I apply the formula, I'm going to get 1. So definitely a plus b power 0, right? Everything power 0 is nothing but 1 only. Clear? Done. All right, now if I ask you to calculate a plus b power 1, so here if you apply this formula, right, in place of n if you write 1, so you are going to get only a plus b, right? So here that means coefficient is 1, here coefficient is 1, right? A plus b, right? Now here if I ask you to calculate the formula of this one, a plus b square, so definitely you have studied this formula, you remember this formula. I think 100% of you remember this formula, right? A plus b square is nothing but a square plus b square plus 2ab. So how we derive this formula? Using this binomial coefficient only we get this formula. Remember, right? So here if you apply this thing here in this formula and 2, and if you calculate this, so you are going to get this. So these are nothing but the coefficient. Here 1 coefficient, here 2 coefficient, and here this 1 coefficient, right? A square plus 2ab plus b square, right? So these are nothing but coefficients, right? And here if you apply a plus b cube, so this is the formula. Using this we are going to get this formula, a cube plus 3a square b plus 3ab square plus b cube, right? And these are nothing but the coefficients, these green colored. Okay, so here if you see, first time we have 1 here. When my n is 0 we have 1. When my n was 1, then I have 2 ones. Then when my n was 2 here, right, then I have something like this, 1 2 1 here, 1 2 1, right? And when my n was 3, then I have something like this, 1 3 3 and 1, right? Here if you see 1 3 3 1. So this is nothing but Pascal triangle, right? This is nothing but a Pascal triangle. So remember this word, Pascal triangle. So this is how we form this Pascal triangle. So during college placements, right, this was the important question. I'm not sure what placements, but during your semester exams related to this programming, any programming language, C++, Java, so sometimes they ask to print the Pascal triangle, right? So like print the star pattern like this in Pascal triangle format, right? So 1 1 1 like this numbers, right, using Pascal triangle everything. So why was they asked such type of questions, right? So this is nothing but my Pascal triangle here, 1 1 1 2 1 then 1 3 3 1, right? Okay, so now this is simple Pascal triangle, right? Now if I ask you Pascal triangle mod 2, and here Pascal's triangle mod 5. Tell me the value of Pascal's triangle mod 2 and Pascal's triangle mod 5. So that simply means whatever the values we have here, I have to, for mod 2 I have to just do the modulo with 2, everywhere. If I ask you Pascal's triangle mod 2, right, like this, and if I ask you to do the Pascal's triangle mod 5, that means 1 modulo 5, 1 modulo 5, 1 modulo 5, here 1 modulo 5, 2 modulo 5, here 3 modulo 5, like this everywhere. Okay, everywhere, here also, here also, here also, right? So this is what we need to do if I ask you to do the Pascal triangle mod 2 and mod 5, right? So here if you do mod 2, you are going to get like this 1 1 1, and here if you notice one pattern 1, and here this is nothing but from this side what is the value, from this side what is the value, nothing. So from 1 only, from this side what is the value, from this side what is the value, 1, and here 0, right? So 1 plus 0 1. Here if you see, this is nothing but the, this one is nothing but a combination of 0 plus 1. This 2 is nothing but a combination of above 2, this 1 plus 1. This one is nothing but combination of this and this side, so this side nothing, so only 1. This one is combination of this and this, so here this side nothing, 0 plus 1 1. This 3 is nothing but the combination of this one and this 2, 1 plus 2 3, 2 plus 1 is 3, 1 plus 0 is nothing but 1. So like this. Okay, 1, very easy, 1 1, then 1, then 2, then 1, right? Then here 1 3, 2 plus 1 3, then 1, then here 1 3 plus 1 is 4, 3 3 is 6, 3 plus 1 is 4, then 1 plus 0 is 1, right? Like this you have to form, right? This is how we can easily form this Pascal triangle, right? Here I just showed you the formulas how we get this. Okay, so now if you do the Pascal triangle mod 5, so you are going to get something like this. Okay, for Pascal triangle mod 2 you are going to get something like this, and for Pascal triangle mod 5 you are going to get something like this. So for n is equal to 0, this is the value. For n is equal to 1, these are the values. For n is equal to, these are the values. For n is equal to 3, these are the values for the Pascal triangle mod 5. And this side for n is equal to 0, we have values for Pascal triangle mod 2. Okay, all right. So if I ask you to calculate the value of this, C 8 by 3 and then mod 5. So first, what is a this? First let's solve this part. So 8 factorial, 3 factorial, 5 factorial, you are going to get something like this 56. And if you do the 56 mod 5 here, you are going to get 1, right? Now using Pascal, how you are going to solve this? Using Pascal, how you are going to solve this? Okay, so using Pascal you can solve it like this. So this is your n, this is your k, right? And mod 5, I am asking mod 5. So first we have to convert n and k, right? This n and k to base 5, right? So this is decimal format, right? 8 by 10, so I have to change it to base 5. So in base 5 we are going to get 1 3. Let's see how. So 8, right? So this is not a binary form, this is base 5. So 5 0 5 1 5 2 5 3. So this is natural 1 5 25 125. So here this 5 I have to take one time, and this 5 by 0 I have to take 3 times, right? So here if you see, this is how I'm getting 1 3 5, right? 1 3 5 means 1 times 5 power 1 and plus 3 into 3 times 5 power 0, right? So this is how I'm going to convert it to base 5. Same way, this is the n, this is k value. I'm going to convert both of them to base 5. I'm going to get something like this. So here we are getting digits like 1 3, 1 and 3. So digits are nothing but 1 and 3. And here we are getting digits like this 0 3, so 0 and 3, right? So this is the first pair I'm going to pick. This is at least significant bit position, right? If you see 1 3, so this is the least significant bit position, this is, right? Then after this we have to take, so first we have to solve this part. So instead of solving this bigger 8 by 3, so I can simply solve these smaller parts, right? These smaller parts I can, and these smaller parts are in base 5 only. So we have base 5 values, small values only, right? So here 3 3, so in Pascal's triangle 3 3, so this 3 I'm taking, then 1 0 I'm taking, right? In this, so 3 3 At 3 3, what is the value? Pascal triangle 3 3. This is mod 5, right? So n is equal to 0, n is equal to 1, n is equal to 3, 2, n equals 3, right? So 0, 1, 2, 3. So at n is equal to 3, at 3 index we have 1. So 1 I'm going to take. So here I'm taking 1, right? And then here Pascal triangle 1 comma 0, right? 1 comma 0 means this one and this 0, right? So 1 comma 0, so and n is equal to 1, and at 0 we have 1, so 1 I'm going to get. So I'm getting 1 only. So here after that we have to just multiply these two, 1 into 1, these two values, we are going to get 1. So this is the one we are going to get. So this is the shortcut, right? So if you don't apply the shortcut, then you have to calculate like this using factorials, and this can be very big, right? It is difficult to find the factorial of the big numbers. First you have to calculate the factorial, then you have to calculate the inverse factorial of this one also. So that is some other way to do this. Okay, so we have solved the problems using that approach as well. Not this particular problem, but we have applied this logic, right? Inverse factorial and all that things, inverse factorial and factorial. We have solved many problems using that logic as well, but in this problem we are going to apply this shortcut, right? So here if you apply this, so here also you are going to get 1, and here using Pascals also you are going to get 1, right? Now what is the benefit, right? Here I am saying modulo 10, I am calculating modulo 2 and modulo 5 like this, right? So here if you see what we are calculating C8 comma 3, right? C8 comma 3. So C8 comma 3, and here modulo 10, that's what we need to calculate, right? Initially this is what we need to calculate. So instead of this, what I was doing, I was calculating C8 comma 3 modulo 2 and C8 by 3 modulo 5. This is what I was calculating, right? These are the two things. So in this side, if you see what was the value that I get in the end, I get 1, right? And here if you solve this part, so 83, right? If you calculate the C83, you are going to get 56, and 56 modulo 2 you're going to get 0, right? So this is the value that you're going to get, 0 here, and here you are going to get 1, right? So now, and here I have applied the shortcuts, here also I have applied the shortcuts, right? Now here C83 mod 10, so here C83 is nothing but 56, and 56 mod 10 is nothing but you are going to get a 6, right? So now how I'm going to get this 6, right? This 6 is what I'm going to get, but as of now I only know this part output and I know this part output, right? So using this A part and using this part, how I'm going to get this 6, right? Let's see that. Okay, so again lot of maths, right? Okay, so here see, we have to find out modulo tens, right? Digits, right, are in this range only, 0 to 9 only, right? So we have to check all these 0 to 9. So I'm going to run one loop to check the possibilities. Maybe we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I have to check the possibilities, right? Let's say from this side I'm going to get some x value, right? So here if you see in this side I'm getting 0, and here in this side I'm getting 1, right? So here can I say in mode 2 side what I'm getting 0, and here in mode 5 side I'm getting a 1, right? This is what I'm getting, right? So I have to find 1x. Okay, I have to find 1x value in which if I do the mod with 2 I'm going to get value equal to mod 2, right? This 0, right? So and here if I do x mod 5, so I am going to get the value equal to this mod 5, which is nothing but 1, right? This is what I am searching, right? My mod 2 value is 0, my mod 5 value is equal to 1, right? And here what I'm searching, I am going to find a number x such that my x mod 2 is equal to the value that I'm getting here, and my x mod 5 is nothing but the value that I'm going to get here, right? This is what I'm actually searching, right? So I have to solve for all the values for x. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all these values, right? We have to calculate. So let's say 6, let's take 6. So 6 modulus with 2, 6 modulus with 2, so I'm getting 0, right? And here if I do 6 modulus with 5, so here also I'm getting 1, right? So definitely 6 is the output, right? So here if you see 6 with 6, 6 is the actual result, right? So using this and this, I'm actually getting 6, right? Here you can try any other number. Let's see if with 0 answer is possible. With 0 mod 5, we are not going to get 1. 1 mod 5, I'm going to get this one, but 1 mod 2 is not equal to 0. No, 1 is also not possible. 2 mod 5 is also not possible. 3 mod 5 is also not possible. 4 mod 5 is not possible. 5 mod 5 is not possible. 6 mod 5, with 6 mod 5, I'm going to get 1. Now see if 6 mod 2 is 0. Yes, 6 mod 2 is 0. So from here, just stop it and we are going to get 6. So see, using these two, right, I am able to get this, right? And what is this called? This is one more theorem actually. Let's do a quick revision of what we studied until now, right? So here first thing is binomial coefficient, right? So different number of ways to choose k items from n. So this is the formula for that, right? So direct factorial computation is too slow for large n and modulo operations, right? So we have to decompose this modulo thing, right? So what we want c n k mod 10, right? So what are the factor of 10? So into primes, right? So that is nothing but 2 and 5 only, right? Clear? So these are the factors, right? Now we have to compute them separately, right? So c nk mod 2 and c of nk mod 5, and then combine using this Chinese remainder theorem. That's what we were seeing here, right? So this is the way to calculate this is nothing but Chinese remainder theorem, right, in shortcut. So what is this Chinese remainder theorem? So if you know the x mod 2 and x mod 5, right, and 2 5 are co-prime, then there is a unique solution modulo 10, right? So if you know the x modulo 2 and x modulo 5 and 2 5 are co-prime, then there is a unique solution modulo 10. So in code we are just going to do the brute force search from x0 to 9 satisfying both the conditions. So what are those two conditions? Conditions are like this: x mod 2 value equal to mod 2 that we have calculated with our here, that we have calculated here, right? This side, and the value that we have calculated this side. This is nothing mod 5. I'm saying shortcut as mod 5. This value and this value, right? X mod 2 is equal to this, x mod 5 is equal to this value, right? So here we have to do the brute force search, right? And here binomial coefficient mod 2. So if all 1 bits in k are also 1 in n, right, bitwise logic, right? So this one, right? So this comes from Lucas theorem modulo 2, right? So binomial coefficient modulo prime can be determined from base p digits. So here I told you this part, right? N and k is equal to k, right? If it is true, then 1, that simply means odd, and if it is false, then 0, that simply means even, right? So this we have already discussed, right? And then how you're calculating the binomial coefficient 5. So here also we are using the Lucas theorem modulo 5, right? So express n and k in base 5. First we need to do this, and then we have to multiply the small coefficient from the Pascal triangles into each pair, right? So Pascal triangle is very easy: 1, then 1 and 1, then 1, then up to 2 and 1, then 1 up to 2 plus 1 3, 2 plus 1 3, and then 1, like this, and then this 1 4. Modulo 5, it is modulo 5, right? So here, then after this you are going to get 1, 3 plus 1 is 4, 4 modulo 5 is 4 only, 3 plus 3 6, 6 modulo 5 is 1, 3 plus 1 is 4, 4 modulo 5 is 4, and then 1. So that's why you are seeing 1 here, not 6, okay? Because we are doing modulo 5, product of this modulo 5, right? Then after that, final combination mod 10 we have to do, right? So I'm just going to run from 0 to 10, and here I'm just going to search, right? So this is nothing but the Chinese remainder theorem, right? So whatever the value we are going to get, we are searching that and we are going to return x, right? So it gives this value, right? Efficiently it is going to calculate this without computing the huge factorials, right? This is the shortcut here. And then in the end, the final two digits we have to calculate, right? So whatever the coefficients we are going to get, right? If we are going to get three coefficients and we have like this a b c d, so first time we have to start from abc, then in this side, and here two digits we need now. So in this side we have to start from bcd, right? So that is why if you see here, I am writing s of j here, and here writing s of j plus 1. This is the reason, right? Simple reason why I'm writing j plus 1 here and this j, right? The final two digits after repeatedly summing consecutive digits can be expressed as this, right? So the binomial coefficient service waits for each digit, right? So this is actually what we need to do, right? A lot of things that we have studied here, right? And this weight thing, right? Don't get confused. So this is what I mean to say, a like a3 b3 c3d. So we are going to calculate the weights, and here s of j means starting from this, j plus 1 means starting from here, right? So now we will just write the code and that's it. Okay, code is going to be very simple, whatever I explained. So I'm going to do the same thing, right? So question is a little bit tricky, right? Here a lot of things are there, right? But it's a good question, right? Okay, so here what you need to do first. So first thing I told you to calculate the length of this, right? So you are simply going to write s dot length, and then after that you are going to calculate the limit as length minus 2, and after that you have to get two values, right? So two values means here if you see 3902, so you are going to get some result here and some result here, right? So this is one sum and this is one sum, right? So I'm going to say sum 1 as 0 and sum 2 as 0 here, right? Then we have to iterate over the string and compute the values. So here I'm just going to write for int j is equal to 0, j is less than equal to limit, right? And here j plus plus, and here inside this I'm going to calculate the coefficient as binomial mod 10, right? And here I'm just going to pass the limit, and here j, right? So limit I was fixing, and j is 0 1 2 until limit, right? And here how I'm going to calculate the sum 1, I have to calculate sum 1 and I have to calculate the sum 2 value, right? These two things I have to calculate. So sum 1 is nothing but sum 1 plus the coefficient that I'm going to get here initially. So coefficient, like first time if its coefficient is 1 or 2 or 3, right? So I'm going to get a side by side everything, right? So here coefficient, spelling mistake, coefficient, right? So sum 1, right? Sum 1 is nothing but sum 1 plus coefficient into and the value at that particular character, right? So s dot char at, and here you have to write j, right? And here you have to subtract 0 from it because you have to consider digit, right? And whatever you are going to get here, you have to just do the modulo with the 10 side by side, right? And here also you have to do the same thing. Okay, so here this is for sum 1 and sum 2. So in first side we are starting from a, then b, then c. Here we are starting from b c d, right? So instead of for sum 2, right, coefficients are remaining same only, but here s dot character at j plus 1 I have to do, right, every time. So here for first time if I'm getting the coefficient as 1 here, so in this side in the sum I have to add a, in this side in the sum I have to add b, right? So here if you see in this example, coefficients are 1 2 and 1, right? So my sum 1 and here sum 2, variables I'm not getting, right? So here 1 into a is 3 and here 1 into b is 9. So right now this is my sum 1 and sum 3, right, or sum 2, right? So here 1 and 9. The next time 2, so 9 plus 2, 9 into 2 is 18, so here I'm adding 18 in the sum, and here 2 into 0, so I'm going to get 0. Then next time 1 into 0 is 0, and here 1 into d, that is number 2, so here I'm going to get 21. In the end here I'm going to get 11, right, like this, and moving, right? Clear. Now in the end here we have to return true when my sum 1 is equal to sum 2, right? Okay, this is done, right? So now after that, what else we need to compute few more things, right? And here, 1 second, this loop ends here, right? Okay, so yeah, good. So here after that, what we need to do, we have to compute the binomial coefficient modulo 10, right? So this is what I want to write the method for this one, right? So here I can simply write private int binomial mod 10, and here I'm passing int n and int k. So I have explained, right, using Chinese remainder theorem, I have to calculate first mod 2 value, right, and I have to find out the value with the mod 5. So in a mod 2, what I'm going to do, I'm just going to call this binomial mod 2, and here I'm going to pass n comma k, and here in this side I'm just going to pass binomial mod 5, and here I'm going to pass n comma k, right? So I'm going to get something, and then we have to just simply search for this one, right? So here I'm going to write find a number x such that x mod 2 is equal to the mod 2 that I have calculated above, and x mod 5 equal to mod 5, right? So here I'm just going to write for int x is equal to 0, and here x is less than 10, and here x plus plus, right? So this is what I'm searching, right, x value, and here I'm just going to write if x modulus with 2 is equal to mod 2, and x modulus with 5 is equal to mod 5. In that case I'm just going to simply return the value of x. That's it. Okay, so this is done, and I'm definitely going to return some value here, and otherwise I'm simply going to return 0, right? Return 0. Okay, so that's it. Okay, this is done, right? And now after that, here let's write the code for binomial mode 2. It is going to be very simple part. So just do one thing here, copy this, and here just rename it to 2, and here only one line of code, this one, right? So here we have to return what? First we have to do n and k, right? So if the value of n and k, if it comes out equal to be k only, right, that means true. So in true we have to return, say it is odd, otherwise we have to say it is 0, right? So this is what we need to do. That's it. Okay, and now final part. So that is also going to be very simple. Binomial mode 5, right? And here we are to use the Pascal modulo 5, right, that triangle. So what I'm going to do here, I'm going to create one 2D array, let's say Pascal triangle, right? And in this Pascal triangle I'm just keeping the values like this, 0 to 4, right? 0 1 2 3 4, right? Modulo 5 we are taking, right, every time. So here we can have values like this, like just 1, right? And here we can have 1 comma 1, and then we can have 1 comma 2 comma 1, then we can have 1 comma 3 comma 3 comma 1, and then after that we can have 1 comma 4 comma 6, 6 modulo 5 is 1, then 4 comma 1, right? Something like this we will have, right? And here I'm going to create one result. I'm going to set it to 1, and here how I'm going to write, here first I have to check when my n value is greater than 0, right? This, or my k value is greater than 0, whatever thing, right? So here if this is the case, then I'm going to calculate the new nd value. So here I'm just going to do the mod 5, right? Modulo 5 of this one, right? And here this kd modulo, kd is nothing but I will say the k value and modulo with 5, modulo with 5. This is what I will do here. And then after that here, if kd value is greater than nd, right? So uh, that simply means choosing more items than available items, right? We if you see, there was one example in which I was choosing 2 books from 5, but we can't choose 7 books from 5, right? So in that case we have to simply return 0. So that's what I mean to say here. Okay, return 0. And here otherwise we have to update my result as, so I told you that we have to solve the individual parts and we have to do the multiplication in the end, right? So here if you see in the end, right, so here we are just doing the multiplication, 3 3 and 1 0, so I'm doing the multiplication, right? So first base 5 we have to convert, right? So for that purpose, so here if you see, uh, what we are getting, we are getting 1 3, right? So I can this is 8, right? So 8 5, so if you do the modulo, right, 5 and 5, so you're getting 3, right? So this is the 3 here, right? This is a 3, that's what you are going to get here, 3, right? So and for k is 3, right? So 3 modulo 5, so 5 into 0 is 0 only, so you are going to get what, 3 only. So you are getting 3 3, right? So here you are getting 3 3. So this 3 3 is nothing but the lowest, the least significant bit here and here, both sides. So you are taking 3 3 here, right? And in the Pascal triangle you are going to search the value of 3 3, right? And this 3 3 is already there, right? So that's what I'm going to do here. So result is equal to result into the value of Pascal triangle, and here nd kd, right? This is what I'm doing, and here do the modulo with 5 of this, right? And next time my here if you see, next time we are taking this 1 and 0 here, right? We are taking this 1 and this 0 next time, right? So that simply means we are moving here and we are moving here, right? So if we are moving here, so that simply means that I have to ignore this one, right? I have to move to next. So here that simply means I have to divide this number, right? Whatever the number I have, 8, right? So I have to divide it with 5. I'm going to get 1 here, so I'm going to write 1 here, and here I'm going to write 0, right? So here that's what I'm writing. So n is nothing but n divided by 5, and k is nothing but k divided by 5. Okay, so this is what I'm going to do here. Okay, and once I do this, right, next time if you see, uh, my n is still greater than 0, right? So again I'm going to reach here, but and again I'm going to calculate this n modulus with 5 and kd modulus with 5, right? Again I'm going to calculate all this stuff, right? So here this is n value, this is k value. So 1 modulus with 5, I'm going to get 1. So this is 2. So here I'm going to calculate that next value, and next time 1 modulus with 5 I'm going to get 0 0 both sides, so both become 0. So in the end my result is going to be 1 only, right? So that's what I'm planning to do here. Okay, so let's write the code then. That's it. And here that's it, right? This is done, and here you have to simply return the result. Return results. Okay, that's it. Let's run the code and see if that code if you will try to fix that. Oh nice. So all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.